Hello and welcome along to Unbelievable. I'm Justin Brierley, your host of the programme every Saturday afternoon here on Premier Christian Radio that brings Christians and non-Christians together for dialogue and debate. And we've got some fantastic programmes coming up in 2016, kicking it off with a very feisty one today. I'll be introducing my guests Perry Marshall and PZ Meyers in just a moment's time. But if you're able to listen further this Saturday afternoon, then you'll be able to hear The Profile. Bernie Diamond speaks to Dave Rose. Bernie heads up Christianity Works in Australia. He's also a broadcaster himself, and he's going to be talking about his life and faith and broadcasting career and lots more besides. That's between 4 and 5 this Saturday afternoon. Don't forget that Unbelievable and the whole swathe of programmes as part of Faith Explored every Saturday brought to you in association with Premier Christianity magazine, and you can get yourself a free sample copy. Might be worth picking one up and perhaps subscribing for the new year. premierchristianity.com/free sample if you'd like to receive the latest edition of the magazine. We'll be hearing some of your feedback later on in the programme, of course. We had some great shows towards the end of 2015 that we'll be reflecting on. But right now, it's time to get into today's discussion. And if you want to take part as well, can I remind you that you can email in unbelievable@premier.org.uk. And why not tell a friend about the show that aims to get you thinking unbelievable and how you can listen to it online at premierchristianradio.com/unbelievable. And I'll be giving you the ways to get in touch again a little bit later on today's show. But right now, time for me to stop gabbling, time to get into today's discussion.
You're unbelievable.
Well, today we're asking the question, is it time to upgrade to Evolution 2.0? Perry Marshall is an author, speaker, engineer and world-renowned business consultant. So why has he written a book on evolution? Well, in Evolution 2.0, Perry claims to have found a way to break the so-called deadlock between Darwin and Design. The book includes information on how organisms re-engineer their genetic destiny in real time. It talks about the amazing systems that living things use to redesign themselves, how every cell is armed with machinery for editing its own DNA, and much more. And Perry's even offering a public award for anyone who can answer the greatest question in all biology, he says. Where does genetic information come from? We're going to meet Perry in a moment's time. But opposite him on the show today is PZ Meyers, well known as an atheist biologist who's not afraid to speak his mind on his popular blog Pharyngula. And try spelling that. We'll spell it out for you later. He regularly critiques the intelligent design community and has denounced Perry in the past too, though Perry doesn't claim to be intelligent design, and we'll get to that a little later. He's had a chance to look at Perry's new book and is going to be addressing Perry's claims. So welcome both PZ and Perry to today's programme.
Thank you.
Glad to be here.
Great to have you, PZ and Perry. Perry, let's start with you. This book is sort of a journey of 10 years, more or less.
Yes.
Do you want to tell us about that journey and why you, in the end, became dissatisfied with both intelligent design and Darwinist camps in this debate?
So this started when my younger brother, who has a master's degree in theology, was a missionary in China, and in the space of 4 years became almost an atheist. And we're very close, and there was emails and emails back and forth for a couple of years. And one day I'm in China visiting him, and we're sitting on this bus, and we're having this, argument number 312. And, this has been going on a trajectory, and he is very smart. And, I just was feeling like I was losing ground, and I found myself grabbing for science. And I said, Brian, look at the hand at the end of your arm. You don't think that this is a long series of accidents or that produced this, do you? And he's like, well, actually, yes, I do. And he kind of pushed back with a neo-Darwinist view of things. And I knew two things. I knew, yes, I did have my engineer's intuition about this. On the other hand, I knew, without him even telling me, that most biologists would be more inclined to agree with him than me. I knew I didn't know. I have an electrical engineering degree. I knew that there are things in engineering and in science that are powerfully counterintuitive. And I knew I didn't know. And but what I did know was that engineering and science are a lot less ambiguous than theology. PZ might agree. And I said, you know what? I've got the same questions Brian has. I'm going to let science settle this question for me. And I went down the rabbit hole. And I'm an obsessive person, and I bought probably 200 books, and I started reading scientific papers, and I said, I'm going to get to the bottom of this, and I'm going to find the truth about this. And I think it's probably going to inform where I go in the faith department. Well, so for a while, I just floundered helplessly. Mm-hmm. I would listen to both sides, and all I could decide was I'm not going to ignore any verifiable fact, and I'm not just going to learn quote unquote my side or whatever the party line might be. I'm not even sure what it would have been anyway. But I'm just going to take all the information and try to touch the bottom of the swimming pool at some point. Well, I got to a point, so it was very unsettling at first. The waves would toss back and forth, and both sides kind of made sense, and both sides didn't, and it would go. There was a point where I first touched the bottom of the swimming pool, and it was recognizing that because I had written an Ethernet book in 2002 for a major professional society called the ISA, which was for process engineers, I knew how ones and zeros work. I knew how code works. And I came to realize that all of the math and all the principles of code apply to DNA. Now, DNA is code. Cells are more than code, but at the very minimum, that the principles of communication applied to the cell. And now I could begin to break this apart. And I realized, you know what? Evolution is a software engineering question. At least I can make a substantial amount of headway starting with that. And I found the tremendous body of literature connecting genomics to communication theory, and there's journals on bioinformatics. And so then things began to make sense. Now, to fast forward the story quite a bit more so we can get into this discussion, I realized that error correction and error detection were absolutely critical to any kind of communication process and any kind of DNA replication. Yet the Darwinian view was that random copying errors, among other things like population genetics and gene flow and things like that, were major drivers of evolution, and that it was inevitable that copying errors and things like that would inevitably produce new structures, new organs, new features, and natural selection would select them, and that you would have a constant improvement just naturally with time. But everything I knew about software said software doesn't work that way. And having written an Ethernet book, copying errors never, for all practical purposes, they never help. So I had a giant discovery moment when, well, let me just say that for a while, so I'm looking at evolution and I'm going, I find lots and lots of anecdotal evidence that there is evolution. I don't think the creationists are right on this. I don't think this is all fake. However, the mechanisms that they're telling me about don't make sense from mathematically and engineering ways. And then I discovered the work of Barbara McClintock. And her story is she kind of approached problems like a hacker, and she was hacking corn plants in 1944 using very measured doses of radiation, and she damaged a chromosome of a plant, and the plant threw her a curveball. It did something she totally did not expect. And if I might use an analogy, what she had done was she had ripped a page out of a novel. Mm-hmm. And the plant, so if you can imagine ripping a page out of a novel, giving it to one of your friends who's a writer and saying, I want you to fill in the missing page by reading what's before it and after it, and use words and sentences that are already in the novel and make it all make sense. And this is essentially what the plant did. And she called this transposition. The genes, certain genes were moving around and changing the expression. And
it kind of rewrote itself. It sort of repaired itself at some level.
Yes, the cell repaired it. It rewrote its own code. And she presented this at a symposium, and half the people there laughed at her, and the other half were angry. And they were like, who does this woman think she is, suggesting that plants can re-engineer their own genetics? And they didn't accept it. Well, in 1983, she won the Nobel Prize for discovering transposition. And I believe that what she really had done was she was one of the very first scientists to observe evolution actually happening in real time and understand genetically what happened.
I mean, obviously, this is just scratching the surface, which you delve a lot deeper into in the book. But essentially, what I take away from this is that you develop this view, which you say is simply kind of bringing to the surface a lot of the science that's already out there, but essentially not talked about much in the public sphere.
Yes.
That essentially there's a sort of, for want of a better word, intelligence in the cell. There's a purposiveness almost in what the cell does. It's not just a case of, as you say, random mutations naturally selected over a long period of time. There's a kind of a sense in which the cell is doing a lot more than we ever gave it credit for.
Yes.
In that sense.
They are most emphatically non-random. They're anti-random, in fact, I would say. And so now evolution began to really make sense. And Barbara McClintock was only the tip of the iceberg. And then there was the work of Lynn Margulis on symbiogenesis. There was Ono's to our hypothesis. There was epigenetics and horizontal gene transfer. And when taken together, these mechanisms actually explain what's going on, and you can observe them in real time. And I thought this is so much more interesting than what the intelligent design guys are talking about. And this is so much more interesting than the traditional Darwinists are talking about. Why isn't anybody talking?
Okay, interesting. Well, we needed to take a little time to explain where the book came from and the central thesis behind it. So we can begin this conversation now with PZ, who's on the line and is going to be taking part in today's programme. PZ, you've run into Perry's work before. You've not been very complimentary about it. So what's your take on Perry? Do you think he's just recycling sort of intelligent design perspectives? What's your take on what he's trying to do?
Well, he's trying to put a new twist on it, but he's getting it all wrong. That for instance, when he's what I thought was very telling, it's also telling in the book, is he's a software person, he's an electrical engineer, and he's trying to impose his perspective on biology. So he says, okay, that biology doesn't make any sense when I look at it as the way software works. Mm-hmm. And instead of saying, well, maybe my analogy is totally off base and wrong, he says, what we've got here is a situation where the biology does not conform to his expectations of how it will work. And biology is far more fault tolerant than electrical engineering. You can't directly compare it to software or code or anything like that because it's got a lot more complications going on with it. Then on top of that, in his book, what he tends to do is throw out science buzzwords like transposition. And the transposition discussion is a good example of this. He throws them out, but he doesn't really understand them. He's got McClintock totally wrong. McClintock's work, which was marvelous work, and it was not initially accepted because it was difficult stuff. If you read her papers, she's got an amazing mind. It's really complicated, really difficult things to understand, and that's largely why it wasn't immediately accepted. But she was very convincing because she brought the data to bear. But all of her work was on something called genetic instability. Okay, it's not about cells engineering solutions. For instance, this stuff on bridge breakage fusion that Perry mentions, that's about random chance breakage of chromosomes that have exposed ends. They tend to refuse, and then when mitosis or meiosis occurs, they break, and they break in random places, not in designed, engineered, planned places, but in an entirely random way, which means that the progeny of that cell will exhibit greater genetic variation than the parent. There was absolutely nothing in McClintock's work that argues against the importance of chance in this business.
Well, can we maybe start to open up that area before we progress on to any more? Just from the point of view of,
okay,
you're saying, Peasy, at base you think the analogy is all wrong. Perry's come to this as an engineer. Well, this isn't computer engineering we're talking about. This is biology, very different thing, different types of tolerances, different kind of thing going on. And then you've obviously got some specific criticisms about the way he's interpreted that particular work that he spoke about. Okay, the obvious question that Peasy has aired here, Perry, is, as I asked, why is an engineer, no matter how good he may be at engineering, writing a book on evolution? You aren't a qualified scientist in that sense, and a lot of people will probably throw your claims out the window just on that basis alone. Why do you believe an engineer does have the right to throw his hat into this ring?
Well, we build models in science, and all scientific descriptions are models. All scientific descriptions are analogies. If I drop a steel ingot off the building onto the ground, I can use calculus to calculate its trajectory, but the calculus is not a steel ingot, and it's going to have a margin of error. The question at hand is, do the models of information theory apply in biology to the rearrangement of code? And we have huge bodies of literature going back to the 60s that say, yes, it does.
That DNA is an information code. It's not simply like an information code. It is an information
code. And I would certainly acknowledge that it is more than just a computer program, but it is not less than a computer program, and the rules of information entropy and all of that work. Now, Peasy said that biological systems are much more fault tolerant. The reason they're more fault tolerant is because they have layers and layers of error detection and error correction. So when radiation damaged the chromosomes, the plant repaired the chromosomes non-randomly. So yes, the damage was random, but the repair was not.
Peasy, why do you think he's got this research so wrong exactly? Can you explain?
I have no idea. That's very bizarre, because what's going on in McClintock's models are that chromosome ends are broken, and they tend to fuse back together. Cells hate single-stranded DNA just hanging out there. So what they'll do is they reanneal with the two broken ends will stick together. And then when the cell divides and they have to separate, they will break in some random position on the chromosome. The only repair mechanism here is that it doesn't tolerate dangling ends, okay? It fuses dangling ends together. But the actual repair is, in essence, randomly damaging to the ends of those chromosomes. McClintock also studied transposition, which is basically where there's an enzyme that copies out a piece of DNA and then inserts it into some random other spot in the genome. It's a well understood phenomenon. It's actually used in a lot of biotechnology techniques, and that again is also a random process. That often what happens when you have a transposition is that it inserts that copied sequence into a place that's damaging to the cell, or shifts regulation, or in many cases will be in a totally neutral place and does nothing at all.
Perry?
So there's two problems with what Peasy said. One is that that error correction in this case is just repairing broken ends. And the latest Nobel Prize discusses 3 layers of error correction which result in a copying error rate of less than 1 in a billion base pairs. And the correction of the errors is explicitly non-random. Transposition is also non-random because if you get a book on transposition, it shows that transposable elements tend to land in specific places and specific patterns. And if you read McClintock's work on this, what's going on is explicitly non-random. Now, Peasy's claim that it's random is not mathematically provable. Okay. And what I found was that in every instance when I started chasing things down, I would find a pattern rather than evidence of randomness.
I mean, what Perry sees as patterns, do you just see as, I don't know, what do you see it as, Peasy, if it's not a pattern and some kind of a purposiveness within the cell?
Well, of course it's a pattern, but it's a random pattern. Patterns can be random. So when McClintock describes the patterns of variegation in corn, for instance, that are induced by these breakage models of the chromosome, what she was actually seeing is variation in the structure and the color of the tissues that was random, that was driven by random processes. It's hard to argue that there was a scheme or a plan behind them, because we understand the mechanisms for how this was generated, and we can see exactly how it happens. And it doesn't seem to involve any kind of design elements. There's no engineer inside the corn plant deciding where things go.
Okay. You believe that there is some kind of an engineering principle going on. I don't know if you would hazard a guess at how that happens, but as far as you can see, Perry, you observe it happening in all that you can tell.
I predict that there is a mathematical model or matrix that is dictating what is going on, and that is a testable hypothesis. Peasy's assertion that it's random is not a testable hypothesis because it's not even possible to prove that it is random. So, Peasy, my question for you is, how do you know that it's random, and where is your proof?
So in biology, randomness is an operational property. What you do is you do the experiment, make predictions about the results you will get. And what you typically see in these kinds of experiments is that you can't predict where the mutation will occur. You know, for instance, if you're inducing mutations, you can just predict that it will occur with some frequency. And you do many repetitions of the experiment, and you can get a nice distribution of where mutations occur in each event. You can plot these out, and you can see that they're actually fairly random in what they do. That's all we care about, is that there's a process we can use to determine whether a particular event was predetermined by other prior consequences or whether it seems to be arbitrary. And in this case, when we look at things like transposons, when we look at breakage fusion models, what we see is random variation in an operational sense.
So, Peasy, I believe that you are imposing your view of things onto something and making a statement that you can't scientifically prove. It's mathematically impossible to prove that it's random. And so you're making an assertion that can't be confirmed. Now, I'll give you an example of a way that you could confirm that evolutionary events are random. And they are the very popular fruit fly experiments and radiation experiments that have been done since the early 1900s. If your assertion was correct, those experiments would have produced some consistent percentage of fruit flies or moths or bacteria that were better, had better organs But in fact, those experiments didn't make better fruit flies. The best they ever achieved was getting the organism to activate its error correction systems, again, which were a study of the recent Nobel Prize. But those experiments were very disappointing. Now, if you are right, I believe that those experiments would have been successful. But those experiments failed to do what the experimenters wanted them to do. Instead, what they did was they discovered which parts of the genome cause birth defects when damaged, which then told the scientists which parts of the genome build certain structures.
Quick response from you, PZ, and we'll go to a break and continue this discussion.
Okay. Well, he was cutting in and out there, so I didn't quite get it all, but I got the gist of it. Here's the thing that, when we do these experiments, what we do see is improvement of the organism. For instance, I work on zebrafish, and I work on a highly inbred strain of zebrafish. And what we find is that over time, strains of organisms raised in the laboratory become progressively better at living in the laboratory, which may mean that they are less adaptable, less able to live in the wild. But it's a routine thing that we see all the time. And under the understanding of better as used by evolutionary biologists, they fit the criterion. They get better and better at living in their environment over time.
So, PZ, you are taking for granted that this happened randomly, and communication theory indicates there's no way that those adaptations were random. And my contention is that cells sensing hundreds of inputs from the environment make alterations to gene expression, epigenetics. Maybe there's horizontal gene transfer. There could be all kinds of things. In the case of your zebrafish, I would think that it's probably more along the lines of epigenetics and transposition types of events. And this is why the improvements are observed. It doesn't just happen with random inputs. It happens because the organism is responding to an input.
We will take a break there and allow PZ to come back in a short moment's time. You're listening to Unbelievable, somewhat technical debate today, but we like to do the technical debate sometimes, and two excellent guests to join me for it. We're asking today, is it time to upgrade to Evolution 2.0? That's the title of Perry Marshall's new book. He claims to have found a way to break the deadlock between Darwin and design, and it's all about the capability of the cell to organize itself, to reorganize itself. There's something rather special about the cell. It's not all random mutation acting on natural selection, says Perry. Well, PZ disagrees. PZ Meyers is our atheist guest on the line from the States, and we're going to be continuing this conversation in a moment's time. May the Force be with you, and also with you. As the new Star Wars film blasts off, Premier Christianity magazine brings you the definitive Christian guide to the incredibly popular film series. Plus, we visit Bethel in Redding, California, and find out why many say heaven is coming on earth at Bill Johnson's Church for Continuous Revival, while others claim it's a dangerous deception. Also, discover what craftivism is, 6 things the Bible doesn't say about money, and much more. Sounds interesting? Request your free copy at premierchristianity.com/free sample.
You're listening to Unbelievable on Premier Christian Radio.
Welcome back to the programme. I'm Justin Briley, your host for Unbelievable this Saturday afternoon, and we're kicking off with a great debate between Perry Marshall and PZ Meyers on this, the first Saturday of 2016. We'll come back to their debate in a moment's time. If you want to respond to anything you hear on today's show, or perhaps hear later on in the programme, then do email in unbelievable@premier.org.uk. You can also find us online at facebook.com/unbelievable for the Facebook page, on Twitter @UnbelievableJB to follow me there. All those links and more, plus today's show available from the website page, premierchristianradio.com/unbelievable. Unbelievable. You can find my thoughts there in the blog, some articles, videos, and of course the ways to download the show if you're not a subscriber to the podcast. premierchristianradio.com/unbelievable. Well, today on the programme we're asking, is it time to upgrade to Evolution 2.0? Perry Marshall is an author, speaker, engineer and a well-renowned business consultant, so why exactly has he written a book on evolution? Well, he's been explaining why in the first part of today's programme. And here on Unbelievable, we like to bring people together with very different points of view. That's what we're doing today as PZ Meyers joins us. PZ is a well-known atheist biologist out in the States, not afraid to speak his mind on his popular blog Pharyngula, and we've already heard his response to some of what Perry has been saying on today's programme. And as far as PZ is concerned, nothing that Perry has brought up, or the intelligent design community, or any other form of response to Darwinian evolution has actually managed to, if you like, create an adequate response at this point. Obviously, what we're hearing here from Perry, though, PZ, in that last section is simply that, as far as he can tell, they're simply what you describe as randomness, as the typical, if you like, Darwinian evolutionary model, can just as easily be, and more easily, in Perry's view, be described as this kind of very purposed kind of response to environment and stimuli and so on. And when we do try and do the experiments where we kind of influence that ourselves and try to introduce mutations and so on, it rarely, if ever, produces beneficial mutations and so on. So yeah, feel free to respond, and we'll then move things along a bit in the conversation.
So what's frustrating about talking to Perry here is that he keeps throwing out these words and as if they're magic incantations that explain things. So, for instance, when he was talking about my zebrafish and how they get better at living in a laboratory environment over years, he says transposition. And I'm sitting here wondering, what the heck is he talking about? Transposition is a very specific genetic and molecular phenomenon. You don't simply say transposition as if it solves everything, because it doesn't. Transposition is another mechanism that causes random mutations in the genome. So in a sense, he's right. Yeah, we get random variations in individual zebrafish that are then selected for by their presence in the lab environment that leads to the next generation, the survivors being better able to live in a lab environment. But as far as directedness, there's absolutely no evidence for that. There have been many experiments done with transposons in flies and other organisms. They do have specific sequences they like to zoom in on, but those sequences are common throughout the genome. So you can't simply say that there's some kind of directedness to it, no purpose. In fact, the whole argument rests on the fact that he is proposing this amazing mechanism in which there is purposeful modification of the cell by the cell, and he's the one with no evidence for that. We've got decades worth of evidence in biology supporting the idea of random genetic change.
PZ, none of your evidence supports random genetic change because there's no way to prove randomness in mathematics. Now, what we can do is we can say, does this fit certain patterns? And you said it follows specific, it tends to conform to specific sequences. And, transposons don't just jump to anywhere. There are certain places that they are more likely to go to than others. There is a definite pattern. It's kind of like if you read the newspaper, the letter E is going to appear 13% of the time, and the letter Z is going to appear about 0.1% of the time. And we see a similar statistical profile in genetics where you see specific gene sequences, specific percentages of the time. And if it was actually random, you would not get these, they're called ergodic patterns, which is so, for example, the letter U almost always follows the letter Q in the English language. That's an ergodic pattern. There's ergodic patterns all over biology, and they specifically and directly contradict your claims of randomness.
No, yeah.
You're groaning, PZ. Why are you groaning?
Because he's ignoring all the evidence. Okay, yeah, you've got a metaphor, and you are shackled to this metaphor of a computer code or a language or whatever. It's invalid here. That when we do real biological experiments, we can make predictions about the results based on chance, and they work. They actually work. So, for example, a really simple kind of experiment that I do with students every year is we are doing mapping experiments. We're mapping genes in the genome. And this is a process in which you encourage recombination. You do breeding experiments, and you get random recombination of pieces of chromosomes. And what that means is that if two genes are really close together, there's a low chance that there will be a recombination event between them. If two genes are far apart, there's a greater chance that there will be a recombination event between them, just because of the physical properties of the chromosome. We can do this, and what we see is it works, that every time we can do mapping of genes, we can tell which genes are closer to other genes by looking at recombination frequency. So this is a case where we're using the predictions of chance events in the genome to map out the structures there. Furthermore, when these same animals, these same organisms, are taken and subjected to a molecular analysis, well, for instance, we sequence the entire DNA strand, what we find is that proportionally we're largely correct. Yeah, that chance events do a really good job of mapping out the distribution and location of genes on a chromosome.
But the breakage points are not random. You're moving genes. You're moving genes around, and the genes are staying intact, or sections of the genes are staying intact. They're not just breaking anywhere.
No, they can. Well, let's not confuse this with a uniform random distribution. It's not a uniform random distribution. There are places that are hotspots for breakage, but when you look at this, yes, you do get cases where it breaks in the middle of a gene and you get a recombination event that bridges right at the point of a gene. You get them in the intergenic regions, but those are larger, so you're more likely to get them there. That's the whole point of the experiment, is that when genes are far apart, you get many more recombination events between them. And when they're close together.
Now, as a layman coming in here, okay, between two people who obviously disagree on, and I'm not following every aspect of this debate, but if I could try and boil it down, as I often try to, you're saying on the one hand, PZ, when you get these events going on in the cell at the genetic level, when you look at what's happening when a cell's repairing itself in some way or whatever it's doing it on the basis of kind of statistical probabilities will kind of play their part, and something will happen, but you can see that it's happening because of the physics of the thing and the way it all plays out. Perry's contention is, on the other hand, is that no, there's something really purposive going on here, that in some way that the cell itself is exhibiting almost a desire, let's say, to repair itself, rather than it just being the random events kind of that, when all added together, do create something that ultimately helps the next generation to improve and all the rest of it. I've probably not described that brilliantly, but
no, you're actually. I think that's a good point to make. Is that yes, you would expect that if there was intent, that this cell would be trying to optimize its condition, trying to select for, without selection, just doing it by itself, designing, engineering a better solution. But the thing is, when we do those kinds of experiments, what we're typically comparing is deleterious and wild-type alleles. So we've got an allele that's actually deleterious to the organism, and we're looking for a recombination event with a healthy allele. And so what will happen is that by the distance separating them, they will sort out into some organisms. For instance, it will get two deleterious alleles, others that will get a healthy one and a deleterious one, and others that will get two healthy alleles. One prediction is if this was a purposeful event, you ought to get more with a double healthy combination, right?
So for
and
you,
it
just looks like what you would exactly expect from your point of view.
Right. What we find is that the distribution of the deleterious traits and the distribution of the healthy ones are dictated by chance, not by the well-being of the poor fly that's going to inherit them.
Okay, what's your response to that, Perry?
There's a video. It's on the Evolution 2.0 Facebook page at the moment, where the University of Reading damaged a gene related to the tail of a bacterial flagellum, and so the flagellum didn't have a tail, and they came back after the weekend, and the organism had repaired some gene and now had a tail.
Okay.
Now, we see this over and over and over again when we look at genetic repair, that the cell is constantly trying to maintain the integrity of the genome. And again, the latest Nobel Prize is specifically about the error correction. There's 3 layers of error detection and correction. The cell is militantly defending itself against random errors. And to give an analogy that listeners would understand, PZ, please tell me if I'm misquoting you, but is suggesting that if this were a newspaper article, the words and phrases could get broken up in all kinds of unspecific, statistically random places and rearranged, and sometimes they're helpful. And I'm saying they're actually obeying the rules of a grammar, and the words are moving around intact, or subsets of words, like words with 2 parts are being.
Yeah. There's an
rejoined.
editor somewhere
There's
in the background who's making sure that you don't just end up with a scrambled article.
Yes.
In some way. I mean, I'd like to move this maybe to the bigger picture, because I'm obviously not going to get you guys to agree on these specifics about these genomes and so on. But I mean, one thing that you make the suggestion of in the book is that the junk DNA debate that's been going on for the last few years, where you believe that this is an example of the way in which your thesis is kind of being borne out in some way. Do you want to just talk to that, Perry, and we'll have PZ respond?
Yes. So, Craig Venter was asked not too long ago, what is your opinion about junk DNA? And he said, a lot of arrogant people have prematurely announced that our 90% of our DNA is junk. And he's not willing to jump to that hasty conclusion. I think that's a very hasty conclusion. Nature is not nearly that wasteful. Now, PZ says a lot of interesting things about junk DNA. He says, junk gibberish with occasional bits of translated codes that convert to proteins with regulatory elements. PZ, your view of the genome as this kind of junkyard, or I think it's completely wrong, and I think that time will prove that wrong. I think it's an anti-scientific position to take.
Throwing down the gauntlet there, PZ. Just explain briefly, for the sake of listeners, what junk DNA is and why you think it is a good indicator of why evolution is, in that sense, a random process at bottom.
Okay. Well, yeah. So junk DNA, it's a complicated term. There's lots of things that have been called junk DNA that are not junk DNA, but roughly 90% of the human genome has no purpose along the lines of assisting us in our life. Okay. It has no functional role, no functional human role, although it may have some selfish genome roles to play. So I have to throw the gauntlet back because, yes, I read Perry's section on junk DNA, and it was disgracefully dishonest. This is simply awful what he says here. I'll just quote it from page 273. He says, ENCODE's findings were unambiguous. At least 80% of our DNA is active and necessary. If you deleted it, our bodies would fail. Our children or grandchildren would be missing something critical that they need to survive. That's a complete lie. I will say that right up front. Not even ENCODE, and I have a lot of disagreements with ENCODE. I don't think they did a good job, but not even ENCODE would agree with that. That's simply not something that they determined at all. That the ENCODE experiments, they defined function as simply binding any other protein in the cell. It's the loosest possible definition of function. They have done no experiments to determine whether those elements are active or necessary, and they definitely have not done any experiments in which they've deleted some of the junk DNA to see if it has an effect. So to make that claim, this is very characteristic of his book, is that he makes these sweeping, strange arguments that are informed more by his prejudices than they are by actually evaluating the facts appropriately.
Okay.
For another thing he says, the burden of proof that junk DNA is truly junk is on them until they understand everything and explain every nuance of the genome's operation in precise detail. Until they can build a cell from scratch, their job is not done. That is also false, because most of the junk DNA, we actually know what it does. That, for instance, there are transposases that are part of the junk DNA. They have no function for the cell. There are reverse transcriptases that are relics of past viral infections. There's a lot of the junk DNA we have categorized. We know exactly what it does, and it does not contribute to the well-being of the organism.
It's kind of historic, hence the name, junk DNA, that
Yes.
played a role at one point in our evolutionary history but no longer does. And for you is yet another reason to show why this, the idea of purposiveness
and we actually know what it does. If you find a sequence, there's sequences called lines, for instance, or transcriptases, and we know exactly what they are. We know what their enzyme does. It copies RNA back into DNA, which is not a function that our bodies use, but viruses do.
Well, let's allow Perry to pick up this gauntlet again in order to throw it back across the line.
Peasy is a little bit of gauntlet slapping.
Yeah, absolutely. I expected no less. Peasy says you've completely misrepresented this ENCODE findings, Perry.
So, PZ, has anyone deleted this junk DNA and seen what you get?
Well, yes, there have been experiments in which large stretches of DNA have been deleted from organisms like mice, and most of that has absolutely no effect.
So I would predict that if you run the experiment 10 or 20 or 50 generations, you will find that does get used. It is necessary. It is helpful and useful. And I think it's extremely premature to say that it's junk. And if you can't build an organism from scratch, again, I go to what Craig Venter said. He engineered a synthetic genome and injected into a cell and got it to work. And, if you did this on a grander scale and you let the experiments run long enough, I think you would find that there's a whole bunch of stuff in there that's not junk. And one of the reasons I believe this is true is, the human genome is only 750 megabytes. It's about the size of a CD. Considering that 750 megabytes contains most of the instructions for building human body, yet Mac OS takes about 7 CDs and Windows takes 20. So first of all, I'm really impressed that the job gets done in 750. What you're saying is the job is actually being done in 75, which is just flat out extraordinary. I don't think you can get that much good code in 75 megabytes. And if you can, it's the best code I've ever seen. And so I think it's really premature.
You don't see that this metaphor is totally self-refuting? You're trying to compare the human genome to the information in code on a CD, and you're pointing out that it's really, really tiny. Even if we count all the junk DNA as functional, it's still really, really tiny. Doesn't that tell you right there that maybe you're making an inappropriate comparison? That you're dead wrong on trying to shoehorn the information in a cell into your rather naive conception of digital information from an electrical engineer's standpoint?
Well, I don't think that all of the information for building a human body is in the genome. I think it does reside in other places in the cell, but it's a remarkably small instruction set that builds a remarkably sophisticated machine. Again, we're using metaphors, and
I mean, Peasy's fundamental objection, though, is that you've come at this as an electrical engineer, a software engineer, and you're seeing the biological processes with that kind of set of filters. And Peasy says it's not the same discipline. You've got the wrong analogy here. What I'm interested to hear from you, Perry, why you think this is an absolutely valid analogy for biological systems.
Well, two reasons. Craig Venter is not just a software engineer. He's a biology engineer, and he's very good at it. Mm-hmm. And he says this is premature, and he's got a lot of credibility with me. And secondly, it's because bioinformatics is such a rapidly advancing field, as is systems biology, that when somebody violates a basic mathematical principle, namely information entropy, and I know that in all of the other analogous systems, what he's saying would never work, then I question his model. And all I'm saying is what's going on here is non-random, and the non-random hypothesis is more consistent with the spirit of science than the randomness, because as soon as you say random, inquiry stops. There's no further dissecting of what's going on. There's a pattern here.
PZ, do you want to come back on this?
Yeah, I would love to hear Perry question his own model, because he's not doing that. Over and over again, what you do is you tell me, well, from my perspective as an electrical engineer, this doesn't work. It can't work. And I'm telling you, yeah, but biology does work, so maybe your perspective is wrong. Maybe you're coming at this from a completely invalid angle. And yet you just come back and insist on applying these fallacious ideas about electrical engineering to biology. That it's like we're in a constant circle here where you refuse to consider the possibility that maybe you're wrong.
Do you think...
I would also...
Sorry, yeah, go ahead.
I also have to point out one other thing, and that is, every time I get into an argument with a creationist, they fall back on this appeal to authority. Craig Venter is a very smart guy. He's really good at what he does, but he's not an evolutionary biologist in any sense of the word. He does not do evolution. He does brute force molecular biology. And so to argue that because Craig Venter is unfamiliar with the evolutionary arguments against his interpretation doesn't hold any water with me at all.
Well, it's his brute force molecular biology that I respect, because he has to build a functional cell, and he doesn't really concern himself with where he came from. Your junk DNA theory comes from where you think it came from or how you think it got there, and I believe you're wrong, and the proof is in the pudding. If you can build a successful cell, then you must know something about the genomics, and I think he knows.
We're going to take a quick break again, and we'll have time for starting to sum things up. And I want to ask Perry in the next section, as we start to draw to a close, about your Evolution 2.0 prize, and see whether PZ might have a chance at winning this. I think the prize money is up to $3 million, believe it or not. So we'll find out about that. Also, how this all in the end ties into God, because we do like to talk about God as well on Unbelievable, not just information, design, and biological systems. And so, let's tackle that one a little bit as well as we start to draw the programme together. You're listening to Unbelievable with me, Justin Briley. My special guest today in studio is Perry Marshall, author, speaker, engineer, as we've heard. And he's written this book called Evolution 2.0, in which he claims to find a way to break the deadlock between Darwin and design. And we'll continue on with PZ as well, PZ Meyers, well-known atheist biologist, on the show to challenge Perry's assertions about biology and design and so on. So come back again in a short moment's time for the final part of today's programme. Hello and welcome along to the final part of today's Unbelievable programme, the first programme for 2016 of the show that aims to get you thinking every Saturday here on Premier Christian Radio. And we encourage your feedback as well. We'll be hearing some of that towards the end of today's show. If you're listening later on today on Premier Christian Radio, you can hear the profile. And today, Bernie Dimott speaks to Dave Rose. Christianity Works is what he heads up in Australia, and he's a broadcaster too. So listen to his reflections on life, faith and his ministry between 4 and 5 this Saturday afternoon as part of Faith Explored. Faith Explored brought to you in association with Premier Christianity magazine. And if you'd like a copy of the latest issue of the magazine, I can fully recommend it, being the editor. I'm a little bit biased, I suppose, but no, it is an excellent publication, and we do offer free sample copies to people in the UK. If you'd like to get hold of a free sample, go to the website premierchristianity.com/free sample. I've been promising you some extra... Loads of great shows still to come in 2016, and next week we'll be asking whether reconciliation between Israel and Palestine is possible as we look at the ongoing conflict between Arabs and Israelis in the Middle East. 3 guests will be joining me to discuss that issue. Dr. Salim Munaya, he's a Palestinian Christian, Lisa Loden, a Messianic Jew, and also Andrew Sibley, who's the author of a book on the church, the Jewish people and the struggle for identity. So look out for that same time next week between 2:30 and 4 here on Premier Christian Radio. Right now, it's time to conclude today's debate.
You're listening to Unbelievable on Premier Christian Radio.
As we conclude our conversation today, we've been talking about whether we should upgrade to Evolution 2.0, and the fact that Perry Marshall's book is called that probably gives you a clue to the fact that he's spent his life in computer and software and electrical engineering, and he's sort of brought that perspective to biology. He's kind of set himself the puzzle, no small one, of breaking the deadlock between Darwin and design. And in this new book, he claims to have shown that there is actually a middle way, a different way of conceiving of the cell. I'm not sure that our other guest, P.Z. Meyers, thinks this is anything other than intelligent design and creationism dressed up in a slightly different way, but we'll allow them both to have their say as we start to conclude today's programme. P.Z. Meyers, an atheist biologist, he was on the show several years ago, but has kindly come back on to do battle with Perry on the programme today. If you want more information on either of my guests, Evolution 2.0, well, you can simply Google it, but if you want to go there fast, cosmicfingerprint.com/evolution will give you the details about the book, and you'll find the blog for PZ at Pharyngula.com, spelt PHARYNGULA.com, or just Google P.Z. Meyers, probably easier, to be honest. But anyway, it's been great having you both on the programme today, folks. Before we come back to you, P.Z., Perry, you're a bit of a person who likes to throw challenges and gauntlets, as we've already experienced in the programme. One of the things you've offered is a prize for someone who can solve this riddle in a kind of naturalistic way. Do you just want to explain what this Evolution 2.0 prize is? Yes,
so... the genetic code is one of the central discoveries of all modern science. And, when I began to understand, encoding, decoding, copying, all of that, everything began to make sense. And what I observed was that all of the other codes that we know the origin of are designed. We, of course, don't know where DNA came from. And we don't know of any codes that aren't designed that fit the definition of a code. And so early on, I was going around and I thought, I've got a really awesome God of the Gaps argument. But I kind of shifted my position because, I got this discussion with my brother and he goes, so Perry, so what do you expect scientists to do? God did it and then go out to lunch, come on. And he had a point. And when you shift from ideological concerns to doing the practical work of science, all science can do is peel the onion another layer and another layer and another layer. And maybe this is solvable, and we should understand where codes and where information come from. I heard Richard Dawkins say the origin of life was a happy chemical accident, and I was appalled at what an unscientific answer that was. And so I decided to put together a technology prize. And so with a considerable effort, forming a company, forming a private equity investment group, right now we're offering $3 million if someone can produce a patentable process that generates codes without cheating. And I think this would be a very valuable thing to achieve.
And would that effectively disprove at some level your view that the cell is doing it itself, or what would be the purpose, I suppose?
I think it might tell us something about deeper principles in the universe that we haven't yet discovered that might explain a lot of what goes on in biology. I mean, biological organisms are really amazing. I'm sure Mr. Meyers will agree with that. They are amazing. And I think there's some big pieces of the mystery that we are missing.
What do you think about Perry's prize, PZ?
I think it's a sham.
You're not going to put your hat in the ring and try and win this $3 million?
No, because there's no way he's going to give the prize to anybody. If I were to say, okay, I've got one for you, here it is. It's called DNA and genetics and biology. There is no designer behind it. It's a code that spontaneously emerged and has evolved over 3 billion years. He's not going to accept it. He's going to say that doesn't count.
I guess that's exactly the issue he's saying is this is precisely a code which, in every other instance that we have a code of a similar kind, we know it's been designed and engineered and so on. Why would we assume that this is the only counterexample to that, I suppose, is Perry's point.
Well, one good reason is that the code evolved when there were no humans around. Humans are really good at generating codes and signaling and all that kind of stuff. But, this is a case where we weren't around 3 billion years ago, so we're off the hook on that one. But I would say that the bias goes the other way, that Perry has said specifically that all codes are created by a conscious mind. This is not demonstrated. This has not been shown. What's far more interesting is that naturalistic processes can generate something as complex as a cell. And so just to assert that all codes are created by a conscious mind is simply short-circuiting.
Is that an assertion on your part, Perry?
It's a misquotation. All codes we know the origin of are designed. And PZ, you said it spontaneously emerged. Could you please give us evidence through a repeatable scientific process that confirms your assertion?
First of all, let me just say that was not a misquote. It's on page 192 of your book, where you say all codes are created by a conscious mind. There's no natural process known to science that creates coded information.
Well, that was the way I originally stated it in 2005, and then you'll see as you turn the page that I updated it a little bit to my current stance.
Which is no difference from your original stance.
Well, all codes we know the origin of are designed.
Okay, let's get to your question. How do we know that these are a product of natural processes? It's because we've got historical information, so we can't repeat history, of course. It'd be nice if we could, but we can't. But we've got historical information about when these codes originated, and it was at a time when the Earth was an oxygen-free hell. And so there weren't our kinds of intelligences around at that time. It also arose entirely in single-celled organisms. So unless you're going to argue that those single-celled organisms were intelligent, that kind of shows that that it had to be a natural process that generated them.
So you're assuming that it was a natural process, but you can't reproduce the event. And we don't know that much about it.
Can you? Are you going to simply assert that it was magic, or that it was a god who appeared, or whatever, that just did it with a wave of his wand?
Well, I'm trying to get away from magic, which is why I'm offering a prize for somebody that can actually produce an experiment rather than make an assertion.
I mean, we've got to the God question, which I did want to get to eventually, because what are you saying, I suppose, Perry? If you're right and PZ is wrong, let's say, and that really there is this extraordinary ability in cells that most of science has not woken up to the fact of, that has this that means it's not random, that there's this kind of purposive directedness to the way that organisms change over time that's built in, from the first seed, I suppose, the first DNA molecule that appeared. It was all there and ready to roll. Are you saying we can only actually, at present, explain that as the product of a conscious mind? And by that, we're probably going to be talking about something a bit like God, I suppose.
Well, currently that would be the inference, but I am reluctant to make God of the gaps arguments and pronouncements, and what I would really like to see is somebody to make real progress on this issue, because my theological views don't hinge on God magically creating a cell. Maybe there is a principle that we have not discovered that gets you from matter to information and to cells. And if that exists, we sure should find out what it is. And if it's a scientific theory, it's repeatable, it's based on principles. And, PZ's not giving us any principles. He's asking for a free diplomatic passive immunity, if you will. And I'm saying, really, there's very little we know about origin of life that currently qualifies as science, and let's improve that. That is what I'm saying. I don't believe in pitting theology against science. I'll tell you what I ask for diplomatic passive immunity is I believe God created a universe that is orderly and structured and discoverable and directional, and all the rest is discoverable because evolution makes the universe an open book. So my bias is to believe that we can uncover the mysteries, but there is at minimum a principle that's being ignored here, and I would love to find it. And I'm very serious about finding it. This is not a joke.
All right. What do you have to say to that, Peasy, just as we start to close out now?
Oh, well, a couple of things. I would recommend that he read, for instance, Nick Lane's recent books on this subject. Currently, what a lot of people are pursuing is this metabolism first model of the origin of life, where it's not a matter of code, it's a matter of chemistry. And that seems to be really successful. I would also point out that we do have a lot of information about the origin of these things. There have been a number of studies, for instance, where we do comparative genomics, and we ask, okay, what's in common with every creature on Earth? And we can thereby work back and figure out what the early gene set was. And doing that, we can determine something very specific about what genes were present in early organisms, what kind of environment they lived in, what kinds of chemistry they had to do to survive. And what we see is, again, a pattern of common descent derived from these ancestral organisms that implies, of course it doesn't prove, but it implies that if we keep going back, we'll get simpler and simpler, and we can figure out what those early organisms were. And that is a productive scientific approach, rather than saying, well, it can't happen, that all codes are created by a conscious mind, therefore there was no natural process that could generate those. If we're scientists, we're looking for natural processes, and that's what real scientists are doing. They're not sitting around writing books based on electrical engineering to impose their views on a discipline totally inappropriate to that perspective.
So I don't think you're going to get a good review on Amazon from PZ, Perry, but why? What if someone is teetering on the edge of getting hold of your book? What reason can you give them to pick it up?
When I started reading evolution books, I was disappointed, would be a mild word, at the lack of rigor that I found in popular books by Richard Dawkins, Bill Nye, Jerry Coyne, people like that. They told you very little of any real substance about how the evolutionary process happens. They told you what happened, but they didn't tell you how. As I went down the rabbit hole and discovered things like horizontal gene transfer and symbiogenesis, I found this extraordinary experimental evolution, which many people were strangely silent about, and this tells that story. I said, this story needs to be told. People can come to philosophical conclusions on their own, but they at least need to know what these experiments achieved.
Well, I'm glad for PZ taking up the challenge at the very least to come on and debate it with you.
Yes.
Because I think there's lots of people who simply wouldn't take that up in the first place. But thank you, PZ, for being on the line to us. And if you want to find out more about PZ, Pharyngula.com or look him up on Google. And the same for Perry, cosmicfingerprints.com/evolution for more on Evolution 2.0. In the meantime, gentlemen, both, thank you for being with me on the programme today.
Thank you, PZ.
Sure.
Unbelievable with Justin Brierley.
Well, hope you enjoyed today's interaction. Don't forget we love getting your feedback as well to the show. So if you'd like to get in touch, unbelievable@premier.org.uk is the email address. You can find us online as well, all the links and much more available, plus listening back to today's show, downloading the podcast and all of that jazz from premierchristianradio.com/unbelievable. A quick note that Perry is going to be putting up pretty soon, I think, a transcription of today's show and his notes as well alongside it. So that'll be available from cosmicfingerprints.com, his website where he deals with this kind of material. Now, a quick message here from Ed Atkinson, who's one of the founders of the Unbelievable discussion group that meets regularly in London for discussion between skeptics and believers, as sort of an offshoot of Unbelievable, the radio show. And he wants me to know that the next discussion group is happening on Monday, January the 11th, and it's on Is Naturalism Rational and Justified? Should be great. You can find more info at the meetup.com website, the Unbelievable Christian and Skeptic Discussion Group, and that's worth going along for. So if you want to find out more, I'll make sure there are details as well on the Unbelievable Facebook page. That's on Monday, January the 11th. Well, we're going to look at some feedback going back to the programme we aired before Christmas between Peter Hitchens and Terry Sanderson. They were debating secularism, Christianity, whether we're abandoning our Christian heritage in light of a report recently on faith and public life in the UK, which recommended cutting back the role of Christianity in various ways. Well, we'll come to that in a moment's time. A quick message here, though, firstly from Erin, who said, a long-time listener and Christian apologist enthusiast, congratulations on 10 years of programming. Keep up the good work. I just listened to the 10-year anniversary podcast. I've listened to every podcast and enjoy them weekly. I just wanted to say that David Robertson is my favourite guest. I love a lot of apologists and theologians like William Lane Craig, Frank Turek, Greg Kuchel, Habermas, N.T. Wright, to name a few. But David Robertson is my favourite after listening to him on your show. I've read his books too. I was disappointed to hear some of your listeners don't like him. How could that be? He's awesome. Get him on as often as possible. Thank you very much, Aaron. Marion in Romford in Essex was listening to the programme that I mentioned between Peter Hitchens and Terry Sanderson of the National Secular Society, Peter Hitchens himself, a columnist for the Mail on Sunday. And they were debating whether the Christian heritage of the UK is history and whether we abandon it at our peril. She says, I turned on the radio, wanted to say that Christianity didn't just fall on the planet out of nowhere. This is the fullness of the Hebrew Scriptures. Jesus fulfilled Scripture. He didn't bring a new religion. Christ is the Greek word. The Hebrew word is Messiah. And this one from Simon in Oxford says, hope you're well. Just a quick message to say I really enjoyed that show. Thought it was excellent. I thought it was very telling that when pressed on the question, Terry Sanderson could only bring himself to mention Christianity's positive influence on art. His overall historical knowledge seemed to be very weak, and his very benign view of humankind may be laudable, but I don't think the evidence paints such a rosy picture. Hitchens, by contrast, may have overstated his case in places, but he was right to query what Sanderson was advocating to fill the vacuum, as even atheists like Nietzsche have pointed out that a lot of what we cherish in society will have to go if God is removed from the picture. Thanks again. No need to respond to this. I hope you had a lovely Christmas. Thanks for the great shows. Anne says, I agree with Peter Hitchens that Christianity has had many benefits on society. It says no one should steal, lie or murder, that we should be honest in business, love each other, be good workers, honour our parents and forgive. It sets high ideals to aim for. It would be a better world if these values were kept today. We wouldn't need PIN numbers and passwords if everyone was honest. It's hard for society to function without a trustworthy population. Criminal gangs now make fake medical drugs and fake safety equipment even, which is the dangerous result of when ethics disappear. Ryan in Kentucky says, quick reply to that show. I must say I side with your atheist guest in his optimism about the moral position of humans, its evolutionary basis and its social, emotive and consequentialist qualities, rather than Peter's deontological position that there must be some ultimate law book out there which we mustn't deviate from. However, I feel I must point out the ignorance of both historical extremes represented to some extent, though not equally on the atheist side, that one might say Christianity has not contributed morally to the greatness of our society, and on the Christian side that Christianity has some reason to claim ownership about that history. In my opinion, philosophy builds on each other throughout history through the minds of those influencing one another over time. And sure, Christian philosophy has played a role, but we mustn't forget the immensely successful secular, non-Christian and pseudo-Christian influences of the Enlightenment and of pre-Christian sources, which have indeed made great contributions to our society. So while it's proper to claim that we ought to be thankful for Christianity being there to spur on our thought on certain issues, similarly, we ought to be thankful for the Romans or the Jews or the Greeks for giving us their environments to spur thought on issues which gave rise to Christianity, and for other people who spurred a movement away from those Christian roots at the right time in history. The real ignorance is that Christians often believe that religion can own certain ideas simply due to its history of participation in their development, and in my humble opinion, secularism's primary virtue is that the ownership of ideas is void. Peter is flat wrong that secularism is absence. On the contrary, secularism is the belief in the public forum, and I see his opposition to the establishment of that forum as law to be quite despicable. To exclude people from having equal say in the law is not just unjust in the present, it ignores and steals their contributions to the history of progress in thought. Christianity has changed much over the years, and it would not have without secular thinkers and other religions pressuring it away from its innate roots. Here on that debate is Joe, who says, interesting conversation on the historical role of the Church of England in UK society, especially for someone not well versed in how the COV has maintained its position as part of the governmental system. Peter Hitchens' belief that the difference between English cultural lawfulness and the apparent lawlessness in the rest of the non-Christian world is an interesting compression of why things are such. Knowing that all leaders are prone to the same failings and moral lapses that plague all of humanity, it seems that Hitchens' thesis is that the historical Christian influence has done the best job keeping the population in check, to do the right thing and not act on their baser natures. That sounds positively Marxist. How one creates a reasonably inclusive system is a huge challenge, but to begin the process with one side claiming all moral authority and the sole originators of anything good in the culture is decidedly uninclusive. Lord knows that we in the States have chosen a revisionist model that makes our founders more Christian than their writings would indicate and are on the verge of cultural war madness. For the sake of the world, we will leave behind hope that cooler heads will prevail and will accept the idea that we all have to learn how to share all that this one planet has to offer with everyone from every tribe and community. And here's Sam, who says, happy 10th birthday. Thank you, Sam. I enjoyed hearing about your journey to where the show is today. I hope you have many more decades ahead of you. On the Hitchens versus Sanderson debate, you say, Peter seemed to be taking a very apocalyptic view, while Terry had a very optimistic view. It seems to me that the core to faith in Jesus is the conviction that evil does not have the last word and that there is a spiritual force for right which cannot be crushed or defeated. I agree with Terry that morality is innate. Man is made in the image of God. Peter seemed very concerned with using the force of law to preserve Christianity. In the first 300 years, Christianity didn't spread because it was the law of the land, but because, as Terry put it, Christians did whatever it is that Christians do. Terry, not being a Christian, I don't expect him to know Jesus of Nazareth commanded us to love the Lord our God with all our heart, soul and mind, and love our neighbour as ourselves, even if that neighbour is our enemy. It was through the scandalous love and joy of the early Christians that Christianity swept through the Roman Empire and became the law of the land. I agree with Peter that we are in a twilight, but we will withstand the coming darkness because the Western foundation is built on Jesus. As we move through the coming darkness, the light will be found in each and every true believer. Think of each of us as a Christmas tree. I'd like to encourage Peter to have faith in the Lord, our Lord of Lords. He has won. We simply need to believe and let his light shine through us via scandalously loving all those around us. And I'd commend Terry for having such a beautiful faith in humanity. While I think he would be far more effective if he saw the true source of his faith, it isn't my place to make him believe, it's Jesus's. I have faith that Jesus has him in the exact right place. Maybe that is to be able to pass on his beautiful faith in humanity to those the church isn't able to reach at present. Thank you very much, says that's from Sam. And Yeah, so quite a few varying responses to that episode between Peter Hitchens and Terry Sanderson. If you want to download it, listen back to it, go to the Unbelievable archive at the website, or equally download the podcast. Lots of people listen every week by the easy means of simply having it downloaded automatically to their podcast. And you can find the feed for that and the iTunes address and all the rest of it from the Unbelievable website, premierchristianradio.com/unbelievable. Just going back a bit further, Jonathan Mitchell on that show between Oz Guinness and Rodney Wilson says, thanks for having Oz on the show. Almost everything Rodney brought up was disarmed by that gentle old voice. I agree with you. Most profound to me was when Rodney questioned, why doesn't God fix it? To which Oz replied, he sent his son. The gospel is powerful. That's where we should set our banner. And that's about all we have time for on Unbelievable today. So thank you very much for joining me on the show. And I look forward to you joining me for the second programme of 2016 at the same time next week.
You're unbelievable.